I mean, this technology has been suppressed, and that's directly, this is the closest thing you'll ever find, directly the function of Tesla. Actually, if you take that off and put a solid core wire here, you can probably put that thing in one corner of the house and put a light bulb with another one facing directly across the room, and when you're going to turn that one, that light bulb over there is going to light up. And I guarantee you it will work, because the way they damp that up, so that the energy doesn't go any further away, so they want to remain everything nice and tight. But this is what Tesla, I mean, look at this, and look at Tesla's book, when he's sitting beside his big coil that's about 10 foot across, that was similar to that, isn't it? Right? I mean, like, we're talking about things like, a wire, wraps of wires. And that's the only recoil he doesn't talk much about. He shows it, but it's not a whole lot of information on those coils, and how it's connected, and how it works, and how should it be working, and whatever. It's like, that's the biggest secret, is how this coil works. But right now, I'm getting a pretty good damn idea with it, because I've been playing it. I mean, that's not a Tesla coil, that's just a spool of wire. But, and on top of it, he picks it up, and he's got no iron. So, anyway, just to let you know what's going on, so, that's way more power in that, with this energy, than we can get from the wall, because we get more heat, and everything is calculated on watts and heat. That's the calculation the scientists like to have, is heat. How much heat can you generate? How much energy do you draw to do this? That gives you your percentage, right? Well, I mean, I just show you the difference. It's just, one would look beside, the expert, right? So, I mean, like, it's, I don't know, call me crazy if you want, but this is real power. I mean, this is really heat. I'm heating up my garage right now. If you run that thing for 15 minutes, I have to open the door, it's too hot. I mean, we boil water on top of it with a pan, you can cook over that here right now. There's a 300 watt stove you can cook, so figure it out. You go ahead and find me a 300 watt stove, which you can cook in it. But that's the way it goes. All right, guys. Instrument, but I cannot get to 60 hertz. Now I test that, the output, and it's very easy to test that. If the output is got a 60 hertz, when you can't find 60 hertz, just a small induction motor, a little fan motor, right? Nothing serious. It's a tiny little guy. And what I did, since I can light up bulb till you go blind, and I got 600 volts at 3 amp, I said if I get 60 hertz in there, that's going to run. I connect it doesn't run. It doesn't have a 60 hertz in it for making that thing run. So, I mean, it's, at that point in time, it's the research, I mean, it's a lot of power coming out of it. You can multiply the power out as many times you want, because now you're in communication form. If you modify this coil, because if you see, all that the coil is made, it's not a single core wire, it's a multi-core wire, right? And it's got probably about, I would say, maybe 30 to 40 braid on each wire, twisted, right? So that controlled, that buff, that's what controlled the communication, how far the communication is going to go up this coil, right? Well, by putting multi-braid, the communication is really low. It cannot project very far because it's bound inside all those windings. So they control the distance. So you only had about an inch of getting induction or transmission, right? So by modifying the board a little bit, by modifying I'm going to disconnect the coil. I'm going to reconnect the amp meter to the light bulb and to the wall, directly to the wall. Now here it is. I'm plugging that to the wall, and we'll see the difference in brightness. I can look at it, no problem. It doesn't hurt my eyes or nothing. And so you connect it to the other one, and then the amp meter is exactly at the same thing, 2.4 amp to run at 300 watts. Now, remember, before, I was running a 500 watt, and also another 500 watts for 2.4 amps. They seem to be the amps and the voltage, which since they have no electrons, they have way more power. I mean, the coil, if you're on the top of the stove and you touch the end of the coil, you will get burned. You will get hit with a hell of a voltage, and you have 3 amp. Believe me, it burned. I got 2 marks. Experience. So, but there's no iron here, right? It's just a straight spool of wire, right? So, when I'm trying to test what is going on, I mean, right now this bulb through this coil, I can bring the temperature of this bulb to 8 above my meter, which is, let's see if we can see clearly here. It's 800 and some degrees, 842 degrees Fahrenheit, and I overload. I go over that and that bulb there when I'm running through the coil. So we're having a massive reaction if you take the system of induction. And to me, the system of induction is very simple. I got one. I burned one already because I just took a thing to it. But anyway, it's good because I know I got spare parts. First thing, you have to have a control panel, which is half of this board, right? That's your control panel. And then you have your transmission board, which is underneath here, right? You got your electronic, you have your DC output cap, and you have, where the coil will mount to. Now the coil is a Tesla communication coil. Very simple, very efficient, and you move energy without electrons. Remember? Tesla was saying you have no loss between point A to point B for transferring the equal amount of energy. So this means what you're sending for one transmitter, the other receiver will have no loss, and it will be the same numbers of volts and energy you're sending. So you have no loss since you're not using electrons. This is Tesla here. Tesla and its prime. I mean, anybody know about Tesla? That's exactly what that is, right? And what they do, they build up instead of using a mechanical device to energize this coil, they use a board. So I'm not too sure because they're using woodpecker effect in here, because when they're looking for the iron on the top of that, I'm getting a woodpecker effect every half second for 5 seconds. You get half a second on, half a second off, and then it goes back to default, or they don't show any iron on the board. So to do a woodpecker effect, to go and send, this means they're sending a bing. The coil sending a bing out, see if it's going to bounce off to any iron electrons and come back to it. And then it tells you, oh yeah, I got an iron, I got a cast iron or any type of iron, which is iron, not aluminum. Okay, now I can start transmitting the resonance, because everything runs on resonance here. This meter which is called the tri-field magnetic field meter, which is not magnetic field, it's goddamn resonance. We find out earlier, right? This guy go crazy. I mean, literally goes crazy. I mean, we should be all dead, when you turn one of those things on. Never mind what I'm doing, just the hot plate on. This guy say we'll all die, right? Because it's a transmitter of resonance. And resonance is on frequency. And what is very interesting is 22 kilohertz, 22,000 hertz a second, which is like interesting because all your three-phase motor drive, induction motor drive runs on 22K. Your washing machine motor, 22K. Your RC motor, all brushless RC motor, 22K. All the controller runs on 22K. Everything is, and communication or transmission is 22K. So we have a pattern here going on with the 22K, which is really important for the iron, because that's what the iron uses. 22K is the best resonance for the iron molecule. So that's why everything is running literally on 22K. And they slash it right now, what's coming out of here. I don't know why I can get the 22K hertz out of it through the instrument, but I cannot get the 60 hertz. Now I test the output, and it's very easy to test that. If the output has got a 60 hertz when you can't find 60 hertz, just a small induction motor, a little fan motor, right? Nothing serious. It's a tiny little guy. And what I did, since I can light up bulb till you go blind, and I got 600 volts at 3 amp, I said if we get 60 hertz in there, that's going to run. I connected, it doesn't run. It doesn't have a 60 hertz in it for making that thing run. So, I mean, it's, at that point in time, it's the research, it's a lot of power coming out of it. You can multiply the power out as many times you want because now you're in communication form. If you modify this coil, because if you see, all that the coil is made, it's not a single core wire, it's a multi-core wire, right? And it's got probably about, I would say, maybe 30 to 40 bread on each wire, twisted, right? So that control, that buff, that's what controlled the communication, how far the communication is going to go up this coil, right? Well, by putting multi-braid, the communication is really low, it cannot project very far because it's bound inside all those windings. So they control the distance, so you only had about an inch of getting induction or transmission, right? So by modifying the board a little bit, by modifying the transmitter antenna, you can pretty well put out a massive amount of power here, out of it, from what you're taking. Now the board takes 5.5 to 6 amp just to energize that board. And then every time you put something on it, all depends what it is, it will draw more amp. So the volume of iron receiving the transmission and heating up suddenly consumes more amp out of, they start pulling out from this coil and to the pan. So I did it with this here and that, and maximum I can get is 2 amp. I mean 2.4 amp, 2.4 amp on both sides. They work perfectly equal. So that's what said. And then the temperature, when you control, you're thinking about working at 2.5 amp of energy and producing over 800 degree Fahrenheit of temperature and melting the inside of a bulb, internally burning the bulb, but not the element. Now I'm going to show you a bulb for the truck, but it did something else because the guy, he was wearing a wireless headset, not a Bluetooth apparently, just a wireless headset. And I believe those wireless headset run on 55 kilohertz. But don't quote me on it, but it's fairly high on the frequency. And the headset pick up a noise when he was going closer to the cell. Now there's no moving part in that cell, just for all the people. There's no motor in that cell. It's just tube of stainless steel. Matter of fact, the exact same tube of stainless steel, right? One inside the other. That's all it is, right? But the cells start to emit a signal, which was a noise, a very strong noise, into the headset. He could not hear it because his headset, is not made to transmit back the feedback. But I could hear it from my computer. I said, and I told him, I said, can you move away from the cell? And the sound goes away. Can you move back to the cell? And the sound get really loud as closer the cell is. And that was interesting because there's nothing moving in that cell. The motor's not running, nothing's running. You just have a 12 volt, the pressure is up at 20 pounds in the cell, and suddenly we're having a radio transmission, right? So people can call it whatever they want, but that was a radio transmission. I could hear it on my end of the line. So, and the guy's in the States, and we do it through the Skype. So if that was not radio frequency, I don't know how much radio frequency is. So at that point in time, that got me really thinking. Got me, first thing, always, thing pissed me off, but that got me thinking. What the hell is the sound I'm hearing through this headphone when you get close to the headset, when you get close to the cell? Well, then I start thinking back to what I was saying. Oh my God, it's true. The cell is talking. So we have resonance into the cell. Well, that makes sense because we're putting DC in it. And like I said before, DC is not an electricity, whatever you want to call it. The AC is resonate at such a high rate, people don't really know about it. Now, why can you not use straight AC to transmit radio? You have to convert everything into a square wave, to DC square wave. As a matter of fact, impulse DC is a much stronger transmission, much cleaner transmission than a square wave. So, there again, why a DC battery, stay charged for years in the door, literally years. The military have some battery, they're good for 25 years. D-cell battery, 25 years. Because they resonate, and literally, the amount of resonance they're losing that they lose slowly is almost being replenished by the sun, because the sun actually is not hot. It's just a big resonating ball. Everybody thinks it's so bloody hot, but the surface of the sun is not. All those pretty picture from NASA and all of the thing there with all the nice colors and the flame coming out ain't red. Okay, it's pure white. So, and you know, it just you know, all this is not mine. That is pure bullshit. And so I mean, if resonance is the culprit of creating energy today, well, everybody, if they know what they're working with, they will be able to do the same thing. So if you learn what resonance is, it's not a wave sign signal. It's just like looking through a screen, a mosquito screen, right? It distorts everything. And it's like try to figure out how many little square I got to look through. It's almost impossible to count that and to keep counting it without losing your spot. So it's very hard to figure it out. But resonance have density. Have density, and resonance also does one thing. Resonance controls gravities. You know, it controls gravities because a certain amount of resonance will let, you know, the electron to keep in order for the gravity to happen, because we all have ion electron. Everybody's got some ion electrons, you know, and the ion electron is the one who's going to give you the most gravities. Now, we have electron, wood's got an electron, plastic's got its own electron, glass got its own electron, copper, everybody's got a different type of electron. Different type of wood have different type of electron from the other wood, right? So, but this is what balances out everything. Now, all we have to do now is figure out, which is we're really close to do, is I know it takes resonance to create a hertz, because a hertz is a volume of something no one can really tell you. Well, the volume is resonance. And then when you achieve a certain volume of resonance, it became 1 hertz. At 1 hertz, you induce that into a copper wire, you know, a certain line, certain size, right? It will give you exactly 1 volt at 1 hertz. And that's when you start. That's your beginning of your recipe, right? So now resonance turned to hertz because of the volume of it. So when we achieve to be able to calculate the density and the mass of resonance into a cubic meter, or cubic foot, whatever you want, cubic inch, I don't really care. As long as you have a starting size and you figure out how much volume of resonance, have that, you know. And on volume again, you know, volume, you take the word volume and remove the word volt. Get rid of it, that guy, and just use volume, because that's what volt reflects, is volume. So let's call it the way it is, right? So now we have the volume. Now we have to figure how to make it release. Well, we know if you have so much resonance and you achieve a hertz, if you induce a wire with it, it will give you 1 volt at 1 hertz, because I did that. So it's not something that's impossible, because I did it. And now we're having a base of calculation. See, the big magic thing is to not, it's not a question of moving a volume. You know, you have to do some movement of volume to another volume, but the biggest thing is we have to learn how to release energy, because energy is around you. All you got to do is release it, but to release it, we have to see. You can't release a phantom, right? You can't see a phantom beside you, you don't see, don't feel nothing. How are you going to release something for this guy if you don't see it, and you cannot manipulate or give him what you want to release it? He can't talk to you, he doesn't talk to you. So, I mean, like, you know, as long as we have no conversation and no agreement, with that energy is invisible and is giving us the finger, right? So I think we have a trick, you know, wind power, whatever, it's also going to create garbage. We all know that. If you don't, well, go jump off the bridge, you're totally stupid. So, if we achieve to make which has been done before, so we should be okay with that. So it's not something new, it's never been done before. We should be able to prime the nitrogen with resonance, proper level of resonance, and to prime the nitrogen going into your motor and turn it to fuel. Just like no different than what the fuel you're putting in your tank. If you think that fuel is fuel, it's explosive, I hate to tell you, but it's not. You remove the nitrogen out of a room and you fill it up with whatever you want, but not nitrogen. You can't even light up a fucking lighter. You can't light up you can't strike a matches and it won't light up, okay? It's nothing there. It won't burn. So, I mean, that fuel of yours is strictly carbon-based. But it does a reaction with nitrogen when it's put in the right quantity for the right volume of air going through, you know, going through your motor or your jet engine, whatever. If the mixture is not right to prime that nitrogen, you have no ignition, or you have over-ignition. You over-prime it, it became too versatile, or you under-prime it and you have no reaction. So you always have to be tuned. The word is tune, right? We always have to tune this thing. Well, the word tune applies for everything. Because if you're not in tune, your body's not in tune, my body's not in tune, your body's not in tune, we all walk like the croupier and we don't feel good. So, in fact, he caused an earthquake in New York with one of his machines. And I know exactly how to do it because it's so goddamn simple, right? As we have a very high volume of resonance, actually, a person with a hammer and an old truck axle is pounded to the ground with a stool and a case of beer beside him, and a small hammer, and if he can tap that thing there long enough, that wave will go to the bedrock and it will start sympathizing and come back to him, and then when it comes to the surface, it sympathizes and go back and forth, till suddenly you will have ground motion. That's how an earthquake works. So it's very simple when you do resonance. ARP, you know, I have a suspicion Japan should be really looking into ARP. What happened over there is too much straight in line with them. You can direct the frequency, you can turn it if you want. All you got to do is use a antenna sitting on a chest grid. And you're just like pulling string of a puppet. You pull the front string, you push the back one, it bent 90 degrees and keep on going. It's a very simple. Resonance can be shot out of the cannon. an extreme speed. We're talking about speed faster than light. That's resonance, not shock wave. Shock wave is not resonance. It became a signal. It became a motion of particles. It rolls in the particles, but not resonance. Resonance goes right through it. That's why you're way faster. So, but I mean, look, mechanic. What do we use? A mechanic stethoscope. Resonance. When you put that in the parts, the resonance comes off the rod. Hit the diaphragm, you hear that loud and clear. When you don't have those, you know, you use a long shaft screwdriver. All mechanic out there knows about that. You want to find out the front bearing of your, the bearing of your pump, of your water pump, the bearing of your alternator, what valve is knocking. You can find that. You put the shaft creep, bring the resonance into the plastic, and the plastic became a speaker for you. So resonance can do a lot of stuff because we have resonance around us. We've been living. Our body runs on resonance. That's why when people come and sit down with my little machine, you know, your body fills up to recharge the volt in resonance. Now I have lots of people testing voltage in people after they're using the machine, and the millivolt increased by 1/3 to half. You know, and all the information I've been saying about checking the millivolt of a small kid. His millivolt is very high because it's growing. You need all that energy to grow. A person who's very sick and dying, the millivolt is very low because he's not rebuilding that. He's just going on a decline to he's got zero. I mean, it's all about voltage, and voltage means volume. Now, the word potential. Everybody have a problem with the word potential with Tesla. But potential is very simple. When Tesla says energy works like water in a hose under pressure, and he's absolutely right. You know, you have to fill up the bucket before you overflow. You can overflow a bucket if you put only half of a bucket in it, correct? So only when you keep pouring it, the bucket overflow. When it overflow, the overflow you use that. So when you have a transformer, you know, and it takes a while, and I was wondering why it takes so long. When I plug up my 4-horse generator, my 1200-watt generator, and I had a light bulb connected to the leg, and my light bulb was not turning on it took sometime up to 3 to 4 minutes on a 50 kV can before my light bulb come up. It was very simple. It was because you have to fill up the can with resonance. It's like water. And then you have to pressurize it, and once you pressurize it, boom, we got voltage coming up, X1 and X2, but not before that. And now I know why, because it is like water under pressure. But you bring a certain amount of volume, and take you to fill up this big volume with this volume under pressure. So you're just filling it up.
Just like the volts on the core there, that didn't show up immediately when you started testing.
That's right, yeah, exactly. The core sometimes, like, you know, like I say, when I do the test with that, if my core is sit all night long by herself, they have no resonance inside. So I have to start tapping it, and it takes a while, and then suddenly, the millivolts come showing up in the core, and boom, it shoots right out, right? It's all about, you know, you got to fill that up with resonance. And that's what a transformer is, right? Iron's got tons of iron in there. And you have to fill that up in the container. Now, people say, oh yeah, pressure, my ass, right? But if you energize a transformer on the pole and you forgot to connect the neutral out of it, you get about not quite 3 seconds. The top of the transformer blow right out. And if there's any lineman up there who installed transformer and they did that mistake, they will be able to tell me yes, because I got a friend of mine, he's a lineman, and they were connecting a 500 kilowatt kV transformer, and they were in a rush in the rain, and they forgot the ground cable, and the lead came out of it, and apparently they're still looking for the lead. It blew up instantly. So pressure, when you have tons of potential coming in from the line, that's mean you get a big hose and you get a lot of pressure. So it all goes back into, you know, what we're talking about. The thing you have to understand is, literally, if you were educated with our schooling system, you can never figure it out, because the schooling system, the only thing it's designed for is to build a wall around you so high you can never get out of that box. And you stuck there with the rest of your life using their mathematics, their equation, their this. You can never come up to your own understanding and own equation. Why? You know, I mean, like, you're a person. You have an imagination. You can come up with your own way how to get to Paris. I'm pretty sure there's more than one way to get there.
Moving. I dropped the magnet. Nothing happened. Now I'm going to go with the other guy here, which is, you know, the ball magnet. And now we have reaction, right? We have reaction. We have reaction, right? So I mean, like, you know, because the field is very strong now. Now, the field's going right through the meter. Now, as you see, now I activate it as resonance, because now when I'm talking, you will see the needle go up, 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 up. It must be a certain, it's my low tone. So as I'm speaking, the needle is moving. Now, I won't speak anymore. The needle's not moving anymore, okay? Now, it goes right through. So I can move the other magnet. There we go, so I'm moving the other magnet. So the field goes right through the instrument. And nothing is going on. That field is dead, except the resonance. Now, here's the instrument, how it works. I'll put the magnet away. Okay? And watch that. It's going to take tiny little, whatever, hard to scratch. Well, first thing, look at that. Oh, sorry. I'm not working with magnet now. I'm going to go to 0 to 3 range. Okay? And I'm just going to scratch on the side of the box. Okay? I didn't build this instrument. The scientific world built the goddamn thing. Okay? Now, if any scientist can tell me why a magnet don't have a live field, that would be interesting. I'm just going to reset this camera here. Give me a second. So, this was just a little demonstration what a magnet is. You know, and when you realize, it took me a little while. I mean, that didn't happen overnight. You know, this thing question, and I got other instrument which the digital, but you won't pick that up because they work. But this thing here is analog. It doesn't fail. That's like it's just like a brick. You know, it's nothing to fail in there. So if it would be picking up any type of electromagnetic field will actually move, and you don't have to move fast. I mean, like if it would move in, I mean, a micro of an inch per second, I would be able to read it, but it doesn't. It doesn't move at all. You know, it's a total. It's like I say, it's just like a wire brush. You know, when you have a wire brush standing in its back and you see all the hair sticking out there, you know, you don't. So as I was explaining the field, you know, sorry I got interrupted there. So, but all the explanation I've been, you know, talking about. Matter of fact, I was just talking to a gentleman. That was a phone call. We're talking about what's going on and stuff like this, you know, from the States and but you know, I want people to understand and you know how electromagnetic really do not work and or do not show the way the world science say it is. You know, all you gotta do is go buy yourself a tri-field. You know, they're like $200 some. Go buy yourself one of those and then do your own test. I mean, like, you know, you don't have to, you know, to be, you know, anything, you know. I just don't. I can't find the word anymore because, you know, when you do the test with magnet and the instrument, right away you will see, you know, it's no live field around that magnet. It's just a bunch of hair sticking out, you know. And when I say magnet, when I use it for my generator, those long fingers, they're just like guitar pick brushing against the coil. And there's no iron in the coil. It's just a coil, just an aluminum coil. So if I'm producing enough of this friction, suddenly I'm producing a hertz, and then suddenly volt shows up because it's in the coil. It's a copper coil, right? It converts everything up. I mean, like, you know, look, you shove a bunch of copper wire up in the air, you know, and you can pick up volts with a voltmeter because the copper, you know, the way it works, it converts the resonance and it carry the hertz and turn everything into volts, and the hertz show up in volts. So, you know, it's pretty simple. Just walk underneath with your voltmeter, a regular voltmeter, and just put a little stick of a little antenna about this long of copper and one clamp, and just walk underneath the power line, and just let the other wire just dangle. It doesn't have to be nothing attached to it, and you will see you're picking up volts. Well, you didn't see any volt coming out from the piece of copper to the power line because it's no volt coming out. It's all in the volume of resonance. What you're seeing is the amount of volt you got is the amount of volume of resonance that little piece of wire picked up and converted to whatever volt it is. But the hertz will always be the same. It won't. Doesn't matter how long the wire is and how short, how big, how fast. It makes no difference. The hertz will always going to be there, right? Because you didn't remove it. You didn't use the hertz. And that's all our instrument going around. No, it used the hertz, but it didn't use anything else. So if you do your own test, just order one of those. Find yourself a couple of magnets, right? And then you'll find out how things work. Then people won't have any bitching about it. You know, do your own bloody work. Don't let people.